In the next couple of videos, we're going to talk about something called a measure of location. And what a measure of location does is it tells me where I am sitting relative to everybody else in the data set. And we're going to look at 3 ways to do that. This video is about percentiles. We'll also talk about quartiles and z-scores. Percentiles are very common. Percentiles take a data set and they divide that data set into 100 equal count chunks. And what we say when we mean equal count is there's approximately the same number of data points in each of those chunks. When we divide data sets into 100 pieces, I need 99 dividers. So you're going to hear us talk about first percentile, 50th percentile, 99th percentile. You won't hear us mention a 100th percentile. That will vary depending on how you define percentiles. We're using the most common definition, the one you'll see in most introductory statistics textbooks, the one you're most likely to see in your specialty. This is the most common. So the question is, how do I figure out what my percentile is? And if I know my percentile, can I figure out what my score was if I have the list of data? So that's what we're going to talk about today. So first is, how do I find the percentile for a data value? Unfortunately, there is a formula for us. So we are going to, why am I having a brain fart here? To find our percentile, we are going to take the number of data values that are less than, but not equal to, my data value. And then I'm going to add to that 0.5 times the number of data points equal to x. And then I'm going to take that whole thing and I'm going to divide it by the number of data points. So my sample size, n. Once I've done that, I'm going to turn that decimal into a percent by multiplying it by 100. This sounds a little weird, so we're going to do 2 examples so you can figure out what that looks like in practice. So let me go ahead and pull that data up. So what I have here is a list of ages for 29 Academy Award-winning Best Actors. This list has been sorted in order from smallest to largest. And that's helpful because I know that when I go to do this calculation, I need to know the number of data points less than x, which means I need to have the list in order so I can figure out how much is less than x. And we'll do 2 examples here. So for our first example, we want to find the percentile for an age of 58. color code. I'll do this first one in green. So I'm going to go through the list. I'm going to figure out where 58 is. Here is 58. I know for my percentile, I'm going to count the number of data values less than 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there are 18 data points less than 58, plus 0.5 times the number of data points equal to 58. And I only circled 158. I'm going to take that, I'm going to divide it by the number of data points, and I was told there are 29 data points in my data set. And I'm going to take that whole thing and multiply it by 100 to turn it into a percentage when I'm done. But first, let's go ahead and do this calculation. So remember to put the numerator in parentheses, because we want to do that multiplication and division in the numerator before we divide by 29. And I get 0.637, which if I multiplied by 100 would be 63.7. And you would be tempted to round this up. Your book is going to tell you to round it to the nearest integer. Some books will tell you to always round down. As a practicing statistician who's been doing this a long time, I always round my percentile calculations down. So I would report this as the 63rd percentile. The reason I do that is what a percentile tells me is it tells me the percentage of data that is less than or equal to my data value. So 63.7% of the data in this data set is less than or equal to 58. If I round this up to 64, I'm no longer guaranteed that 64% of the data is less than or equal to me. That percentile was calculated very specifically. So I shouldn't ever round these up. I should round them down. Because I am 100% certain that 63% of the data is less than or equal to 58. I don't know that 54% of the data is less than or equal to 58. So my suggestion for good practice is round down to the nearest integer, whatever the book says. We're going to try another one for practice because it's good for us. So we're going to repeat. We want to find the percentile for an age of 25. So same process. I set up my percentile fraction. First thing I'm going to do, I'm going to grab a color. I'm going to go in. I'm going to circle 25. I can see that there are 3 data values less than 25, plus 0.5 times, and then the number of 25s I see in the list, and I see 1 out of 29 total data points. And I am fundamentally lazy, so I'm going to go copy what I just had here and retype. So that's the only thing that changed. And I get 0.1206, 0.121, which would become 12.1, which I'm going to round down to the 12th percentile. So 12% of the ages in that list are less than or equal to 25. Another example, if you get your SAT scores back and you were at the 82nd percentile, you know that 82% of the people who took the test the same day you did less than or equal to as well as you did. Doesn't mean they got 82% of the questions right, but it means that 82% of the people did as well as you or worse. So you are above or equal to 82% of the people who took the test. Now the question is, how do I go backwards? If I know my percentile and I have a list of scores, can I figure out what my score was? So, find data value given the percentile. And that gets a different formula. First thing you need to remember is that percentiles are locations in lists. So when I do this calculation, I'm going to find a location in the list, and then I'm going to turn that into a data value. So what I'm going to find is I'm going to find the location in the list, and I'm going to call that I. And I is equal to my percentile over 100. I want to turn it back into a decimal, times sample size plus 1. That's going to give me a location in the list. If I is an integer, find that value in the list. That's your percent. That's the value that corresponds to that percentile. If not, you are going to find, you're going to round I down and up. And then you're going to find the average of those values. Again, that's a little weird. So we're going to go back to that example we just did. We're going to do 2 more examples to find x given a percentile. So for this example, I just had a brain fart. Give me a second. So we want to find the 70th percentile. So I know this person's age is at the 70th percentile. I want to know what that age is. So we're going to find our location in the list, I. That's equal to my percentile over 100 times sample size plus 1. So let's go ahead and type this in. We're going to have 70 divided by 100 times 29 plus 1 is 30. And I get 21. Because that is an integer, I need to find the 21st value in the list. So we get out our highlighter, we start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 21. I don't know why I went back. So 21 is 64. So the 70th percentile corresponds to an age of 74 or 64. Ugh, words are hard. let's go ahead and try another one. We're going to go ahead and find the 83rd percentile. So which age corresponds to the 83rd percentile? So same process. Location in the list is 83 over 100 times sample size plus 1. The only thing that's changed here is my percentile, so 70 to 83. I run that, I get 24.9. So I'm going to find the 24th number, I'm going to find the 25th number, and then I'm going to average them together. So let's start counting. I know 64 was the 21st, 22nd, 23rd, 24th and 25th are 71 and 72. And the value that's halfway between 71 and 72 is 71.5. So the 83rd percentile for these 29 award-winning best actors is 71.5 years old. All right, if you have any questions on percentiles, feel free to send me an email. Otherwise, I will see you in our next video.